Hey guys, today I've got a real quick little addition to our predicting products. We talked about double replacement last time, but there's one little thing that you're going to see today in lab that's pretty important. That's going to be a bit of an addition to double replacement. So we said that double replacement takes two compounds, switches their cations to make two new compounds. So let's go ahead and take a look at this example here. Move my little chart over. All right, so this example is hydrochloric acid and sodium hydroxide. Hydrogen is the positive, chlorine is the negative in hydrochloric acid, and then sodium is the positive and hydroxide is the negative for sodium hydroxide. So those two positives are going to switch, so you get NaCl, sodium chloride, and HOH, which you can also write as H2O. That is fine. Now, the new thing for today is that when you look at these products, you have to decide if they are aqueous, which means they dissolve at AQ, or a solid, which can also have a little down arrow, which means they don't dissolve, and that is called a precipitate. Very important word, that one. Precipitate. So what we're going to be looking at today in lab is a set of 6 double replacement reactions. You're going to predict the products for all of them, and then you're going to determine if they should have formed a precipitate and see if that's what happens in lab. The way you decide if something forms a if it forms a precipitate is if it is soluble or not. Soluble means it can dissolve, which means it's not a precipitate. Insoluble is the opposite. Doesn't dissolve and forms a precipitate. Now, you might remember back from Unit 1 in the indicators of a chemical reaction, forming a precipitate is one of those indicators. So what you're going to have to be able to do is determine if something is one of these compounds, if it is soluble or if it is insoluble. And the way you do that is with a handy-dandy chart. Let's see if I can get this to come to the front. We'll do arrange, bring to front. There we go. All right, so what we're going to do is find sodium chloride and water on this chart. Well, we're going to find sodium chloride. Water is water. It doesn't dissolve in water because it is water. So if it's water, you just ignore it. It's not a precipitate because it is itself, doesn't dissolve in itself, but it doesn't form precipitate in itself. But anyway, we're going to look at sodium chloride. Now, you may already know that sodium chloride is table salt, which means you know it should dissolve to make salt water. That's what happens with table salt, is you can dissolve it. So you might already know that it is not a precipitate because it does dissolve. But here's how you use this chart to figure it out. You've got two sections divided right there into soluble and insoluble. So the soluble side is up top, the insoluble side is down bottom. Remember that soluble means it does dissolve, insoluble means it does not. And what you do is you look at the cation, the anion of your compound that you're trying to determine if it's soluble or not. So for sodium chloride, NaCl, the cation is chlorine. So you go look for chlorine on the list. Chlorine's right there in the soluble section. So we say sodium chloride is soluble. But there's a line over here for exceptions. So sodium chloride, or chlorine, is soluble unless it's with any of those things, which right now it's not. So that's soluble. You write it with a little AQ for aqueous, and you move on. Water, H2O, you ignore because it is the solute there. Sorry, not the solute, the solvent there. So we ignore it and move on. For our next example, we've got ammonium sulfide and lead to acetate. So we got to look at each of those, determine what's positive, what's negative. switch the positives so that you've got NH4 with C2H3O2 and PB lead 2 with S. So you would have to balance the charges, but they're already balanced, so that's nice. The same thing happened in our previous question where it was already all balanced, and then you balance the whole reaction. But you do have to determine if either of these things is a precipitate. You do that by looking at the anion. For this first compound, it is acetate, C2H3O2. And you go find it in the chart. It is up here in the soluble section with no exceptions. So that one is definitely soluble. You put a little AQ with it. And then you go to lead 2 sulfide. Sulfur is the anion there. We go look for sulfur. It is in the insoluble section down here. We got sulfur right there. We go look at the exceptions list and see if lead is on the exceptions list. The list reads compounds of NH4 positive, that's not lead. Alkali metal, that's not lead. Calcium, strontium, and barium. None of those are lead. So this one is insoluble. If it's insoluble, you put a little S. You can put it with a down arrow for precipitate. So this one, lead 2 sulfide, forms a precipitate. Some reactions form one, some ones don't, but it is a good thing to be able to predict when you're seeing reactions in lab. So now go do your lab for today. Some of them will form a precipitate, some of them won't. That's what you're going to have to predict.